Today we're going to talk about time value analysis, and as is the usual case, I'm going to start off with giving you an example of the kind of problem that we're going to try to answer today with the concept we're going to review. And that is case 12, which the very first question is, which bank should Gulf Shores choose for savings account, a certificate deposit, or term loan? Typically, most healthcare organizations have got multiple different banks that they deal with for different purposes. So this is a kind of question that we're going to answer today with today's concepts. And we're going to, instead of a mini case, we're going to cover as much of case 12 as we can in the time we have. Again, just to give you an introduction for a feel for the kinds of things that you will be doing in your casework. So time value analysis. If I was going to ask to borrow some money from you, would you prefer that I repay you tomorrow or a year from tomorrow? Why?
You can invest it.
Right, because money today, repaid today, can be invested to earn a return. So one of the fundamental principles of finance, and microeconomics for that matter, is that a dollar today is worth more than a dollar tomorrow. When you have children, you'll find out that at some age they discover that you start to wonder about, well, where is it you go in the morning? And so our daughter one day, when she was 5 or 6, at the dinner table, she said, what do you do? And so I said, well, I teach finance, which is I teach grown-ups about money. So she thought about that for a second, and she said, well, ask me a finance question. So I said, well, you've got a piggy bank upstairs, you've got money in it. Would you lend me $1? So she looked at me sort of skeptically, like a bad credit risk or something. And she said, okay. And then I asked her, well, so now if I borrowed $1 from you, would you like me to repay you tomorrow or Halloween? You have to choose something that they know that they can relate to your date. So she thought about it for a second. She said, tomorrow. Whoa, 5 years old, and the kid's already a financial genius. So I said, that's great, that's the right answer. Do you want to tell me why you think that? She said, because by Halloween you'd forget to repay me. Right answer, wrong reason. But nevertheless, it is illustrative of a very important point, and that is that money has time value. So if you have a choice between receiving money today and receiving money in the future, only an economically irrational person would prefer to receive the same amount of money in the future as today. So what we're going to do, the concept we're going to cover today, which is probably mostly review for most of you, and extensions to some more complicated analyses, is to talk about discounted cash flow analysis. The first place to start, which sounds like it's trivial, but it's really important to get timelines clearly established in your mind, because it's so easy to make calculation errors because you've got the wrong time period. So in this course, time period 0 means today. So if timelines here are years, and 0 is today, 1 is 365 days from today, 2 is 730 days from today, and so on. So the timeline, the ticket year 1 is the end of year 1 and the beginning of year 2. So the end of year 1 and the beginning of year 2 are the same thing, same date, which is 365 days from now. So this is really important when you start getting into capital budgeting and other kinds of analyses where you've got very complicated cash flows. And you need to specify exactly when these cash flows are going to happen. So timelines are a really important aid to that. So the first thing we're going to talk about is, because money has time value, is calculating money, the value of money at different points in time. So if we're getting money in the future, we can bring money back to today's value, and if we have money today, we can compound it forward to find the value of money 3 years from now. So typically, the first place we start is something called compounding, and all of you should be familiar with this concept because I'm sure your parents had you deposit money in a bank, and then you would see the value of interest going. So in this simple example, we're going to deposit $100 today, and we're going to invest it at 10%. How much will we have in 3 years? Well, fortunately, Excel makes these calculations very simple. So we simply use the future value function in Excel. And you can see it requires 3 different inputs. The number of periods, which is 3. The present value of the payment, which is $100. That's how much we have, and that's how much we're going to deposit today. And the interest rate, which is 10%. So the thing about Excel is that there is a lot of different ways of getting to the same answer. And here's just an example. There's 3 different ways here. You can calculate $100 times 1 plus the interest rate to the 3rd power, or you can take the $100 times 1 plus A4. I mean, you can see all the things there. The one we're going to focus on is the bottom one, which is the future value function. You will use the future value, present value functions a lot over the course of the year. And so all we're doing in this future value function, which is in cell A10, is we're simply saying, first thing Excel wants to know is what's the interest rate. That's in cell A4. The next thing it wants to know is what is the number of periods, and that's in cell A2. And then thirdly, what is the amount to be invested, which is in A3. Now there's a negative sign in front of A3. There are many ways of doing this. You can put a negative sign on the outside as well. The reason for that is that Excel has to assume either it's a cash inflow or a cash outflow. Because you can pay money out, you can get money back in. Excel assumes that it's a cash outflow. So if you want to know what the cash inflow has to be, you have to take the negative of the Excel function. Because, and that's all we're doing here. So let's just keep thinking about it logically. Is this a cash inflow? Then it should be a positive number. If it's a cash outflow, it should be a negative number. You can just use Excel as it is. If it's a cash inflow, you've got to add the negative sign. So similarly, your grandmother may say, I'm going to give you $100 3 years from now, but because future dollars are not worth what they are today, we can calculate what the value of $100 is 3 years from today in today's dollars. This process is called discounting. So compounding is taking money today and projecting it forward. Discounting is taking future dollars and bringing it back to today's dollars. So these processes, compounding and discounting, are exact mirror opposites of one another. Compounding, you're going forward. Discounting, you're bringing back. Again, we can use Excel to find the present value of $100 3 years from now. So the first thing it wants to know, using the PV function now, not using the FP function, because now we're calculating the present value. The first thing it wants to know is, what's the interest rate? And that's in cell A4. Next, number of periods, which is 3, and that's in A2. And then the amount to be received is $100 in A3. So if I were to give you the choice between $100 3 years from now and $75.13 today, which would you prefer?
The same.
They are the same. They have exactly the same financial value. You should be indifferent between those two amounts. If you are not indifferent, then your interest rate is not 10%. You've got some other interest rate. But if your personal rate of interest is 10%, you have to be indifferent between those two amounts. There are different kinds of an annuity. What is an annuity?
Annual payment of the same amount.
Right. So an annuity is an annual payment or a monthly payment or a weekly payment or a daily payment of exactly the same amount received over a finite period of time. All of you have annuities. I bet almost every single one of you. What is the common annuity in this room? Rent. All of you make checks out every month, or most of you do anyway, to pay for your rent. And that is an annuity. You sign a contract, a lease for 1 year, you agree to make 12 monthly payments. That is an annuity by definition. There are two different types of an annuity. An ordinary annuity, Or for example, where you buy a CD or an investment, you write a check today for $100, and then a month from now, or 6 months from now, or a year from now, you start getting interest on that, so that the payments, interest payments, are in the future. Or there's an annuity due, where in fact the first payment occurs today. Which type of annuity is your rent?
Annuity due.
It's an annuity due. You do not move into your apartment and say, oh, I'll write you the first check a month from now. Typically, your landlord will want his or her first check on the day you move in. So your rent is an annuity due. An investment in a CD, for example, is an ordinary annuity. So here now we have multiple years of cash flow. We're not just talking about present value, future value of individual amounts. We're talking about a stream of cash flows. So the question we're going to answer now is, suppose you get $100 a year for the next 3 years. How much will you have in your bank account at the end of those 3 years? And you can see here, essentially what we're doing is we're taking the $100 that you receive 3 years from today. That will be worth $100 because you get it on that day. The $100 received at the end of year 2 will be worth $110, and $100 received a year from now will be worth $121 because there'll be 2 years of interest on it. So again, Excel has a nice little function, the PV function, where now we have, we use the FV function, and we're telling it that in this, that there are, the first thing it wants to know is the interest rate again, the number of periods, and the number of payments that will happen. And that will give you the $331. The present value of the annuity, again, if you know that you're going to receive $100 over the next 3 years, that's $300 spread over 3 years, but we know because of the time value of money that's not worth $300. So in fact, we can calculate the present value of that. $100 received 1 year from today, in fact, is worth $90.91 if the interest rate is 10%. $100 received 3 years from now is worth $75.13. So in fact, when you add those up, you get $248.69. What that means is the present value of $100 received for 3 years in a row is $248.69. It is not worth $300. And again, we can use the PV function in Excel in exactly the same way as I just talked about a minute before. So the PV and the FV functions in Excel can be used to find the future and present values of single amounts or of annuities. You can use both of them for both purposes. Now the question becomes, annuities are great because they're nice constant cash flows. They're the same amount every month. However, and typically when we're talking about capital budgeting and other kinds of issues, we have uneven cash flows. We have different amounts per month. So for example, in this example, we've got $100 a year from now, $300 2 years from now, $300 3 years from now, and negative $50 for 4 years from now. Why might that be a negative? Just out of curiosity. Why would I put that in?
You can have a loss or lose money when you, instead of making money.
Yeah. So this could be like a capital investment. I'm just thinking something that only lasts 3 years. A really old food truck. So you're getting cash in for 3 years when you're selling food, and in 4th year, the thing collapses and you got to invest money to repair it to get back on the road. So you have a renovation expense of $50. So in this case, we've got to bring all those dollars back to today's dollars using the discount rate of 10%. And you can see it adds up to $530. Now, how do we do this in Excel? We have to use the NPV function in Excel. And what this is telling us to do is, if you can see in the bottom in a cell A10, we're taking the NPV of the values. The first thing it wants to know is what the interest rate is, which is 10% in cell A2. Next thing we're going to do is discount the rates, the cash flows in A4 to A7. And that gives us the $530.09.